Now we will discuss about the unit 2, that is types of simple machines. So at first we need to know what is lever. So levers are the simplest kind of machines used in our daily life. So what is actually the definition of lever? So a lever is a rigid, straight or bent bar which is capable of turning about a fixed axis. Okay, so in your book it is given that a lever is a rigid bar which can rotate about a fixed point or a fixed line called the axis of rotation. That means the fixed line is actually the axis of rotation. Okay, so the point or the axis of rotation is called the fulcrum. Okay, now we know that what is effort term. Effort term is the distance of the fulcrum from the point at which the effort is applied. So here in the point A the effort is applied, is not it? So the F is the fulcrum. So the distance between the A and F, that means this distance, is actually the effort term. And what is load arm? We know that the distance of the fulcrum from the point at which the load acts is called the load arm. So here in the point B the load acts and in the point B, right? So the distance between the F and B, that means this distance, is actually the load arm. Okay, so now we will discuss about the principle of lever. So what is the principle of lever? So the principle of lever states that the product of an effort with effort arm is equals to the product of load with load arm. So that means we can say that load into load arm is equals to effort into effort arm. So in this case, load, if we denote load as L, and the effort arm here, it is effort arm, the load arm is BF. So L into BF will be equals to effort means E into effort arm means AF, the distance AF. So we can say that E into AF. So L into BF will be E into AF. So L by E, that means load by effort, will be AF by BF. So we know that the mechanical advantage is the ratio of load and effort, is not it? So mechanical advantage of the lever will be L by E equals to effort arm by load arm. Okay, and always remember that for an ideal lever, it is assumed that the rod is weightless and there is no friction at the fulcrum. Okay, and a lever works on the principle of moments. Okay, so you will learn about it more clearly in your next classes. Okay, so now levers of the first order. So now levers of the first order. In this type of levers, the fulcrum is situated between the load and the effort. So in case of first order lever, the fulcrum is situated between the load and the effort. So this figure 4.5 implies that means this figure implies the first order lever. Here the fulcrum is in between the load and the effort, right? So this is actually the first order lever. Okay, in case of first order lever, the effort arm may be equal to or less than or more than the load arm. Okay, so if the effort arm is more than the load arm, then what will happen? A small effort is required to move the load. Okay, and if the effort arm is less than the load arm, then a large effort is required to move the load. Okay, so thus we can say that as the mechanical advantage is equals to effort arm by load arm, so we can say that the mechanical advantage can be more than 1 or equal to 1 or less than 1. When equal to 1, when the effort arm and load arm is equal, then we can say that the mechanical advantage is equals to 1, right? So but if the effort arm is more than the load arm, then the mechanical advantage is greater than 1. And if the effort arm is smaller than load arm, then that means if the effort arm is less than 1, if the effort arm is less than the load arm, so then we can say that the mechanical advantage is less than 1. Okay, so the seesaw, okay, and a seesaw, okay, a scissors, okay, and the handle of a water pump, they are the example of first order lever. Why? Because if we notice this figure, okay, here the fulcrum is in between the load and the effort. Okay, in case of this scissor, here effort is applied, so it is the point of effort and it is the load. Okay, here it is load and the fulcrum is in between this effort and load, so we can say that it is actually first order lever. Okay, so now levers of the second order. So in this type of levers, the load is situated between the effort and the fulcrum. Okay, this is actually the diagram of the second order lever. Okay, here this is the fulcrum and this is the point of load and this is the point of effort. Okay, so the load is in between the fulcrum and the effort. Okay, so this is actually second order lever. Clear? So here we can say that the load arm is BF, that means the distance between B and F, this point. So this is the load arm. Okay, and what is the effort arm? Effort arm is the distance between this point A and F, that means AF will be the distance from the effort to the fulcrum. So we can say that this is the load arm AF. So here in case of second order lever, we can say that the load arm is always less than the effort arm, right? So we can say that here always less effort is required to move the load, right? And here the mechanical advantage is greater than 1 because the effort arm is more than the load arm, right? The nutcracker, okay, ports of a boat, they are the example of second order lever. Now levers of the third order. So in this type of levers, the effort is situated between the load and the fulcrum. So here this figure implies the third order lever. Here the point A is the point of effort, that means and here the F is the fulcrum and B is the point of load. So we can say that here the effort arm is always less than the load arm, right? So the mechanical advantage is always less than 1, and here we can say that a large effort is required to move the load, right? So sugar tongs, bread knife, they are the example of third order lever. Okay, why? This is an example. This is the bread knife. Okay, here this is the fire tongs. Okay, so in case of this fire tong, okay, the point of load is this, and this is the point of effort, and this is the fulcrum. So we can say that the effort point is in between the load and the fulcrum, is not it? So this is actually third order lever. Okay, so now we will discuss about the pulley. Okay, so what is a pulley? So we can define pulley as, pulley is a flat circular disc having a groove in its edge and capable of rotating around a fixed point passing through its central axis, commonly called axle. Okay, in a way, axle is a fulcrum around which pulley rotates. So this is actually pulley. So this is actually a pulley. Okay, this is the flat disc. Okay, this is the axle. Actually this is the central axis, that means this is the fixed point passing through its central axis. Okay, this is actually axle and this is the groove actually. Okay, so this is a pulley. Okay, so now single fixed pulley system. So what is single fixed pulley? A pulley which has its axis of rotation stationary in position is called actually a fixed pulley. Okay, it consists of a single pulley. It is attached to some high platform and around its groove passes a rope. Okay, one end of the rope is attached to the load and effort is applied at the other end of the rope. This pulley is commonly used in drawing water from village wells. Okay, this is actually single fixed pulley system. Okay, means from the figure we can say that in a single fixed pulley, an inextensible strong string of negligible mass passes around the grooved rim of the pulley, right? So, and one end of the string is connected to the load. Okay, and the effort E is applied at the other end of the string, is not it? And notice that both the load L and effort E acts downwards in this case. Okay, on pulling the string downwards by the effort, the pulley rotates and the load moves up in this case, right? So now what is single movable pulley system? So a pulley whose axis of rotation is movable is called a movable pulley. Okay, so a combination of two pulleys is actually a single movable pulley system. This is a single movable pulley system. Okay, and in this kind of pulley system, the load of say 100 kgf can be raised by an effort of 50 kgf. That means less effort is required, right? So now we will discuss about the mechanical advantage of the pulley. Okay, so in case of an ideal pulley, the effort is always equals to the load. Okay, so in this case mechanical advantage is 1. Why? Because load and effort is same, so we know that mechanical advantage equals to load by effort. So as the value of load and effort is both are same, so then we can say that the mechanical advantage is equals to 1. But in case of actual pulley, the mechanical advantage is less than 1. Why? Because in case of actual pulley, the effort is more than the load. Okay, so that the mechanical advantage is less than 1. So now inclined plane. So if we consider this figure, so if you try to climb over a small wall, then before jumping you need to move a short distance backward, and then you need to run towards the wall before the actual jump, right? So you need to apply a large amount of effort here, right? So but the same result can be achieved by placing a wooden plank like this, okay, along the wall. Okay, so now you can easily walk over the plank and climb the wall and jump, right? So here this wooden plank acts as a machine which helps you to do the same work by applying less effort, right? So this type of machine is called an inclined plane. Okay, and in such a case the mechanical advantage is always greater than 1. Why? Because the effort required to, that means push a load up an inclined plane, is less than the lifting the same load directly, right? So we can say that here the mechanical advantage is greater than 1. Okay, so what is the definition of actually inclined plane? So any sloping flat surface along which a load can be easily pushed or pulled is called an inclined plane. So examples of inclined plane, we know that in some houses we can see this type of ramp, right, to push up the scooters and motorbikes. So this is actually an example of inclined plane, right? We know that when drums or gas cylinders are loaded into or unloaded from the truck, they are pushed up or down the wooden inclined plane, right? So this is the wooden inclined plane. Okay, now what is wedge? A double inclined plane is called wedge. Okay, what is a wedge? A wedge is a simple machine which helps us to tear apart solid objects. Okay, by using a wedge you can easily tear apart a piece of wood which otherwise is not possible. Okay, so this is a figure of wedge. Okay, it is actually a double inclined plane. Okay, and we know that for pushing apart solid objects, the sharp end of the wedge is placed on it and it is then hammered from the wider end with a hammer. Okay, the sharp end penetrates the wood, okay, or any solid object, and it tears apart the object in lateral direction. Okay, this is actually wedge. And we know that the knives, okay, axes, saw, needles, nails, they are the modifications of wedge. Okay,